Hello world and welcome to Learning Java, one byte at a time. This is video 16 in a tutorial series geared at bringing the wonderful wide world of Java to those with little or no programming experience. This video follows up from the last video in which we were discussing variables, and in this video I'd like to go into greater detail with regards to the types of variables that Java has to offer, as well as the ranges of those variables, and the use case, that is, when and why you'd want to use one variable over another. Now, Java essentially has two different classes of variables. They have what are called primitive types, and those are things that are so essential to the language that they're actually built right in. They're always immediately available for our use. We simply have to declare them and assign them values. The other types of variables that Java offers, as we know, are the objects. And the objects, if you remember, are constructed from classes that define them. They're instantiated or constructed using a new keyword, and then they're assigned states and behaviors that can later be used for that sort of functionality. So what's interesting is that while the three types of variables that we've been using, that's the int, which is short for integer to hold simple numeric data, and the string, which is used for holding a string of character or text data, and then the occasional Boolean that holds true or false data, the integer is in fact a primitive type, whereas the string is technically an object. And one thing that might clue you in on that is the fact that whenever we declare a string, we use a string with a capital S, and this usually indicates that we're calling it from an object. However, what's weird is that the string is never constructed using the new keyword, and it's never instantiated or assigned states and behaviors. And the reason for this is because over the lifetime of Java, the string has been so widely and frequently used that it's sort of been grandfathered into the primitive class. And so it really is the exception to the rule. Every other object that you're going to need to create, you'll need to instantiate from a class, and you'll need to construct it using the new keyword, and you'll need to assign it states and behaviors. But the string, although it's an object, we treat it like a primitive in that all we do is declare it and we assign it a value. But what that means is that the string, being an object, does have functionality. And some of the functionality of a string we can actually cover right now. So if we jump back in where we left off at our variables class, we have a string that we've declared and called myString, and we've assigned myString the text value of this is my string. So some of the interesting things you can do are you can call myString and use the dot operator to access some of the methods. One of the methods is called length. And what this does is it returns an integer value that's equal to the number of characters in the text. Something else you can do is you can call dot substring. And what this does is you pass it through an integer value, like let's say 5. It will take that integer value, it will count in that many characters, and then it will start at that point, and it will return the rest as a string value. And so if I had another string that I'm calling my new string, and I set it equal to myString.substring5, the value of my new string will be equal to the words is my string. Something else that's interesting that you can do is, let's say instead of having a string, I declared an int, and I call it my new string length. And I set it equal to myString.substring5.length, like so. So what do you think is going to happen here? Well, Java is first going to resolve the first method invoked, which is substring5, which brings it to the beginning. It counts in 5 characters, and then it starts right there. It then returns this string value to the second method that it invokes, which is called the length, and then it counts out how many characters are in that second substring. And so the integer my new string length is actually going to be equal to not 18, but 13. Yeah, 13. So that's sort of the fun that you can do with objects, especially the string object, is that you can piggyback the methods. Now, we could make several videos talking just about the different functionality of the string object, but just for the purposes of the scope of this video, we'll call it good at that. Just understand that the string is an object, but we treat it like a primitive. And so if we jump over here into a file that I've called range.java, we're going to talk about the different types of numerical data that we have. So if you recall from mathematics, an integer is going to be any whole number. But what if you're working with data that isn't a whole number? What if you're working with fractional data or decimal data, like you're working with currency or something like that? In that case, an integer simply won't do. And so here in Java, we have 4 different types of integer data sets, and we have 2 different types of what are called float data sets, and those are going to be the fractional data or the decimal data. And so of the integers, we have the byte, the short, the familiar int, and then something called a long. And in the float data types, we have the float and the double. Now, each one of these has a different bit depth, and the bit depth is going to represent how many binary combinations the variable can represent. And so a greater bit depth means that it can hold greater numerical place values, or in the case of the float variables, greater decimal place values. And so the byte, being only 8 bits long, can represent the values from negative 128 to positive 127. So there's a very short range of numerical data. And the short is somewhere on the range of negative 30,000 to positive 30,000. The integer, the one that we're very familiar with, suits just about every case in programming, and this is going to be it's some insane number. It's like 9 billion, negative 9 billion to positive 9 billion, or something like that. And whereas the long is twice as big as an int, and it has several digit places that it's capable of holding. I'm not even sure. We'll look at that here in a second. So the question is why not always default to a long? I mean, why not always use the biggest cup as your variable? And the reason being is that the long is 64 bits in depth, which means it has to be allocated that much memory. And we use integer data in Java so frequently that actually adds up over time, and it will actually slow down the iteration of the program. So we typically default to the int, except in cases where we absolutely need that longer data set, and we pick a long for that. So then the other question is, well, why not cap your data down to a short or a byte if you know that it's going to be the case? So if I realize that I'm only going to have data that's going to be between negative 128 and positive 127, why wouldn't assign it a byte? Well, you certainly could, except one of the quirks of Java is that it actually constructs all of these integers beginning with a 32-bit int, and then it converts it either into a long or into a short or a byte. And so, whereas if you stick to an int, except in the case where you need a long, you're actually saving data. If you try to save saving memory. If you try to save that memory by using bytes in cases where you think you're only going to need an 8-bit data type, you're not going to be saving any memory because Java starts with the int object and then converts that to a byte object. And so it's a little quirky, it's a little weird. I don't really have a good explanation for why that's the case, but it is in fact the case. Now, with regards to fractional data or decimal data, the opposite tends to be true. Whereas you have a 32-bit float and a 64-bit double, you would actually normally start with the double and then only default to a float when you knew in fact you only needed 7 decimal places. And so it's sort of the opposite, and it may be a combination of two things. It may be a combination of the fact that a program can become so error-prone when you lose those extra decimal places, and the fact that decimal data tends not to be as widely used as integer data, that defaulting to a 64-bit data type is actually not going to be, the cost savings is not going to be as profound as you would using integer. And so if you're using decimal data, normally default to a double unless you know you're only going to need a float. And if you're using integer data, default to an integer unless you know for sure you're going to need a long. So then the question would be, well, then why ever use a byte or a short? And there are in fact some cases where the program that's accepting the data is expecting that particular kind of data set. And that happens a lot with databases or some methods that would be looking specifically for a byte, in which case you would just go ahead and use a byte. But as far as any integer goes, sticking to an int is usually going to do you. And as far as any decimal value goes, sticking to a double is usually going to do you. Now, the other two that we didn't discuss yet are the Boolean, which we've used once or twice, and this simply holds a true or false value. It's really good for conditional logic and program flow. And then the last one is the char data type. Now, this is a 16-bit data type, and it basically uses a conversion system called UTF-16, which is how most character data is parsed using a 16-bit binary data representation. and it's going to represent everything from a capital A to a lowercase z, and all of the punctuation and all of the special symbols, pretty much everything that you can access on your keyboard, is going to be of some type of char. And in fact, the string object that we've used is made up of smaller char primitive data types. And so what we're going to do is we're going to go ahead and run this program, which is going to display the min value and max value of all of these different types of data types so that we can get a sense of how large they are and their capacity. One thing I want to point out, though, is that you notice that, first of all, these all begin with an uppercase letter. That's an uppercase B for byte and S for short. And here I haven't typed in a lowercase int like we normally use. I've typed in an uppercase I and then the full word integer, as well as long, float, and double, all with uppercase. And so you're probably thinking, wait, doesn't that mean that those are objects? And you're right. So what ended up happening was, as the int and the byte and the short were primitive data types, somebody that was really nice a long time ago went ahead and made objects that were based on those primitive types and gave those objects the exact same capacity and the exact same qualities, and then assigned them functionality and behavior, which made it interesting because it enables us to be able to tap more into these variables. And so if you don't need the functionality, going with just the common int is going to do you good. But if you know you're going to need to tap into some of that functionality like we're doing for the purposes of this program, calling an integer object is actually going to do you better. And those will need to be constructed using the new keyword. And so the other thing you might notice is that the methods that we're invoking using the dot operator are in all caps and use an underscore for the space. And so if you remember correctly, that tells us that these are constants. And with regards to this program, that actually makes sense. I mean, a byte is going to have a minimum and maximum value that are not going to change. And the same is going to be true of the short and the integer and all of the rest. And so it kind of just gives you a nice example of how being able to recognize that as a constant gives you a little more insight as to the functionality of these objects. And so let's go ahead and run this so we can get a sense of the minimum and maximum value of these data types. So we'll jump in here to our command line, and we'll go ahead and execute our range program. And so what this does is it shows us a byte has a value of -128 to 127. A short has a value of -32,768 to +32,767. An integer somewhere upwards of -2 billion to +2 billion. A long is, as the name would suggest, incredibly long. And then here you have a float, and it's actually representing it in an exponential form. This is 1.4, and the e means it's an exponent. So that's 1.4 times 10 to the -45, all the way up to 3.402823.5 times 10 to the 38. And that's just an incredibly long decimal value. But then over here we have the double. That's not times 10 to the -45, but times 10 to the -324. And these are just insane values right here. I mean, so you're hardly ever going to need anything longer than that. But if you do, there's actually another object variable type that's accessible to us called the big decimal. And that's used to have very precise calculations with very accurate monetary units. And we can talk more about that later. In here you see we have our Boolean with the values true and false. And then the character, it looks like it doesn't have any character data presented here, but the min value of a character is actually going to be a blank space. And the maximum value is going to be a question mark. We can look more in depth at the char data type as we move forward to see all of the different data representation it has to offer. But in the meantime, I want to go ahead and just wrap this tutorial up. This kind of makes a good video, hopefully giving you a good idea of the different types of variables and when and why you'd want to use each kind. Obviously, if there are any questions, of which there probably are many, the comment section is a great place to message me. And I hope this has been entertaining and informative, and I can't wait to see everyone back again in the very next video. I hope everyone has a beautiful night, and we'll see you next time.